Good afternoon, Veritas scientists. It is Thursday, April 8th, 2020. Tomorrow is Good Friday, so we have the day off tomorrow. So this is our last lesson of the week, and we will be back on Monday. Let's see, I don't even know what day that is. Monday. We'll be back on Monday. All right, let's get started with this now. So we'll start with some vocabulary for today. Today's lesson is about identifying rocks and minerals. Okay, so here's some two vocabulary words. We want to just make sure that you guys know the difference between rocks and minerals. So number one, a mineral is an inorganic earth material. It was never alive. Inorganic, never was alive. That has only one ingredient. For example, diamond is a mineral. If you broke a diamond into tiny pieces, every single piece will be only diamond. Nothing else is mixed into a mineral. Okay, so when you have a mineral, it is literally just one ingredient. And if I took a hammer to it and smashed it into a million pieces, there's nothing in it except for that mineral. Every single little part of it is that mineral, right? So if it was a diamond, for example, every little piece would be diamond. If it was quartz, for example, every little tiny piece, if I smashed it, would all be quartz. There's nothing else in a mineral except for just that one mineral. All right, gold is a mineral. If you took gold and you broke it, it's only gold. There's nothing else that is in it. All right, so that is that is what a mineral is. It's just one ingredient. There's nothing else. A rock has minerals in it. So a rock is an inorganic earth material, because it was never alive, that has two or more ingredients, and those ingredients are minerals. Okay. Rocks are made up of a combination of two or more minerals. For example, granite rock is a combination of minerals, including quartz, feldspar, and mica. Right? So rocks are made up of minerals. So if you break open rocks, inside of them are different types of minerals. And you can tell what type of rock it is based on what minerals you can find that are in it. Okay? So that is a little rundown. Let's go back to yesterday's question from Wednesday, April 8th. It says the type of rock depends on what minerals the rock has in it, and that's what we just talked about. So the question I gave you was, how do geologists, those are scientists who study rocks, how do geologists identify what type of rock they have found? So here's my answer. Geologists identify what type of rock they have found by first identifying which minerals are in the rock. Okay, rocks are made up of minerals. So to find out what type of rock it is, you have to find out what type of minerals are in it. Minerals can be identified by their shape, color, hardness, luster, and streak. So we're going to talk quickly about these words in a minute. I found some information in a book that we can look at these. Shape, color, hardness, luster, and streak. Those are all different ways that minerals can be identified. Okay, you can look at the mineral shape, you can look at its color, you can look at its hardness, how hard it is. You can look at its luster, which is like if it gets hit by a light, how shiny it is. Does light go through it? Is it dull? Is it shiny? That would be its luster. And streak, if you were to break it into tiny, tiny little pieces, like what do those little pieces look like? What color are they? So like if I took this rock here that I found up on Mount Tom, I think it looks like a piece of coal maybe, I don't know. But it, if you were to scratch it on, I don't want to scratch my table, but if you were to scratch it on something, if I were to scratch it on this rock, this white rock, if I were to scratch this, see the black stuff that comes off of it? That's not a scratch. We're going to look at a scratch test in a second. That would be its streak. Like what color is it if it comes off like that? See, I can just rub that off. Those aren't actual scratches. That would be called this rock's streak. Like when it's got tiny, tiny little pieces of it come off, what color are they? That would be the streak. Okay, so scientists can use that to identify minerals also. All right. Once geologists know what minerals are in the rock, they can identify what type of rock it is. Okay, so in order to identify what type of rock you have to first be able to identify the minerals, and then you find out, well, if it's this combination of minerals, then that makes it this rock. All right, so that was my answer. Check yours, see what it's like, send it to me so I can see what you wrote. You can fix it, edit it first, and we'll talk about these things now. Okay, so let's see, I got a lot of things here today. So we're gonna look at these different ways to identify minerals. Shape, color, hardness, luster, streak. I think they left shape out here, but you can clearly look at something and the shape of it could tell you which type of mineral it is. So here are some, I found this book in my house, mineral properties. So color. Minerals come in all colors, from clear to pink, red, blue, green, and black. So you can start trying to figure out if you were out and you were a geologist and you found a mineral, you could figure out what type it is by its color. By its hardness, it says hardness is measured on Mohs scale. Minerals are graded from 1 to 10. So we're going to look at hardness in a second, but basically a 1 would be soft and a 10 would be as hard as it gets. So a diamond is the hardest mineral out of all minerals in the world. Diamonds are a 10 on this Mohs scale. So something that's soft would be closer to a 1, right? Like sandstone was made out of sand that was, it's a sedimentary rock that formed in layers, right? So that is really soft because it's just sand in it. So that would be like a 1 on the Mohs scale, but a diamond is a 10 on that scale because it's really, really hard. So you can see, well, how hard is it? And we're gonna look at this in more detail in a minute. We're gonna scratch some things and see what is harder than the other. So we'll get back to hardness in a second, okay? But they can basically see how hard is this mineral. If it's too soft, then it can't be a certain type of mineral, or if it's too hard, then it can't be a certain type of mineral, right? So they can figure out what type of mineral it is based on how hard it is. Okay, it's luster, like I was showing you a little while ago. Minerals can be shiny or dull. Some allow light through them, but others don't. Streak. Streak is the name for its color of a mineral in its powdered form. So if you had it cut down into a powder, kind of like when I scraped it onto the black rock onto the whiter rock, the powder stuff that comes off it, that would be its streak. What color is that? Because sometimes you have a mineral, like graphite is an example. Graphite they make pencil tips out of. So if you took graphite, when you look at it, it's like black, but when you draw with it, it's gray, right? So its streak is gray. All right, so sometimes it's a little bit different. When you look at it, you can't quite tell, so they do like a little streak to see what color it is when it's powdered. All right, so with that, those are just some ways that they can identify what minerals are using these properties, right? So we're gonna look at two of these now. We're gonna look at hardness, and then there's another thing that we're going to talk about, which is the crystal structure of its particles. So we're going to look at that in a minute. Also, we're going to do a little experiment. Okay, so let's see. Where am I today? All right, I got a lot going on. Okay, so here we go. Thursday, April 9th. It says, here are 2 ways that geologists can identify rocks/minerals. So they really can't just identify a rock yet. First, they have to identify what minerals are in it, and then they'll be able to identify what rock it is, right? So these are how to identify kind of both of them, right? But thinking about minerals, one of them is a scratch test. That will test its hardness, like we just read about in the book, how hard it is. So a scratch test, what it says here is harder minerals scratch softer minerals. If you rub 2 minerals together, the softer mineral gets scratched and the harder mineral does not. Okay, so I don't have minerals, but I got what I think is a good example. I have a piece of, this is plastic. It's like a little light for my keychain. And this is a toy I used to put, it's metal, and I used it to put together one of JoJo's toys. So I have metal and I have plastic. If you rub them together, the softer one is going to get scratched and the harder one is not going to get scratched. So I think we all know that metal is harder than plastic is, right? So if we rub these together, you're going to see that the plastic is going to get scratched, but the metal is not going to get scratched because it's harder. So you can tell with minerals, if you took 2 different minerals like a diamond and quartz and you rub them together, the diamond's not going to get scratched at all. It's super hard. It's a 10 on the Mohs scale, where quartz is softer. So this one is going to get scratched and the diamond's not going to get scratched at all. So they can rub different minerals together and say, oh, well, I know a diamond's extremely hard. How hard is it compared to that? Then they can rub it against something that's soft and they can see, well, is it harder than that one or is it softer than that one? And then they can use that to help them identify which mineral it is. Okay, so let's do this quickly. Oh, trying to set my phone in between my knees here. Okay, so if we had this piece of plastic and I rub this piece of metal on it, all right, I'm just gonna rub them together. See that my plastic got scratched. The metal is not scratched at all. Okay, scratch them together. The harder one is not going to get scratched. The softer one is going to have scratches on it. Okay, so that's the same thing with minerals. You have something harder, scratch it against something. The harder one's not going to have any scratches on it. The softer one is. Let's see if we'll be able to tell with these two rocks. Okay, we scratch them together. Okay, now I'm going to wipe away the streak because we said that that's actually the little powder that's coming off of the black one, so that's not necessarily a scratch. Okay, but you can still see this black one is not scratched at all. Like there's no scratches on it. If I look closely at it, it's the same as it was before. There are no scratches on it. Where this one has got some scratches. It's all scratched up right here on the surface. I don't know if you can tell with the camera, but this one, the harder one, didn't get scratched. This one must be softer. It got scratched. Okay, so you can tell minerals, what they are based on how much they scratch, or which one scratches the other one. Okay, last thing we're going to look at is the crystal structure. So each mineral has its own unique crystal structure. So you can tell what mineral you have if you look using a magnifying glass at its crystals. Okay? Scientists / geologists can look at a mineral's crystal structure using a microscope or magnifying glass. So we're going to actually do this, okay? It's going to take till Monday to see the results of it. But what I got here is I got a cup with water in it. It's just a little bit of water in the bottom of a cup. Just got it out of my sink. Okay? Then I have salt. Okay? So this is a mineral. So if we pour this into the water, it's going to dissolve. And then I can mix it in, and it's going to become part of the water. It's going to dissolve into the water. So what we're going to do is I'm going to leave this until Monday. It's now Thursday, so I'll leave this for 3 days sitting in my window with the salt in it. And what's going to happen is the water is going to evaporate, and what's going to be left behind are going to be the salt crystals. And we'll be able to look at those crystals, just like a scientist would if they were trying to identify a mineral. They can look at the crystals, and depending on the shape of the crystals will tell them what type of mineral they have. So some crystals are shaped like a hexagon, kind of like this, right? They got like 2 pointy ends. 1, 2, 3, 4, 5, 6. Yeah, that's a hexagon with 6 sides. Some of them are shaped like a cube, right? Some of them have more than 6 sides, right? Some of them are shaped kind of like diamonds, and they're more like 3D, kind of like this, right? So all the crystals are different. Sometimes they're boxes. Sometimes they got like little lines in them. Sometimes you see them and they literally look like this with these lines on them, right? So you can look at the crystals, and that's how another way that they can identify what type it is, because every mineral has its own unique crystal structure. So no two minerals have the same crystals. They're all different. So diamonds, if you look at their crystals, and gold, if you look at their crystals, and silver, if you look at their crystals, they're all going to be different from each other. So they can look at the crystals and identify it. So we'll do this, and then I'll mix it. So here's my salt. I'm just going to pour some salt into there. Won't go crazy with it. Now I'm going to stir it in. Oh, just going to stir it so it kind of dissolves a little faster. Stirring the salt in. Okay, and now we're going to leave this, and when the water evaporates, it's going to leave all the salt crystals behind. Okay, and we're going to be able to see the crystallized structure that I'm talking about that a mineral will have. So I'll leave that out to sit. I'll put it in the window. I know it's not very sunny out today, but hopefully we'll get some sun in the next few days, and we'll see what happens with that, and we'll be able to see the crystals that I'm talking about that minerals have that are different for every mineral. So that's another way that they can identify what type of mineral they have. All right, so here's our question for Thursday. I want you guys to answer this, and we'll go over this first thing on Monday morning, because tomorrow, like I said, we have no school. It's Good Friday. So number 1 says, describe the rock cycle in detail. Include the following vocabulary: sediment, sedimentary, igneous, metamorphic, and mineral. We're going to go back to the rock cycle. Then I'd like to talk a little bit about a new topic that is related to how rocks are formed, and we'll talk about that on Monday. I got a pretty cool story, I guess, that I can talk about. All right, so that's it. Have a great weekend, and enjoy your day off tomorrow, and we'll see you next week. Thanks, everyone.